All right. Today we're doing an activity where you will have to recognize equivalent expressions. And what I want you to understand about this is, I'm reminding you that if I have a parenthesis, we worked on parentheses, and we have the 2 outside, it's just this distributive property of multiplication, right? So 2 times x is 2x. And 2 times negative 2 is
0.
2 times negative 2 is what?
Negative 4.
Negative 4, right? So you have 2x
I'm right.
minus 4, right? Look, these are equivalent expressions. And is this equivalent to that?
No. Yes.
I have, how many x's do I have?
2.
And I have how many negative numbers here?
2.
Yeah, but if I subtract negative 2 from negative 2, I get what?
Positive. Positive 0. Negative 4.
Negative 4. These are equivalent, right? Equivalent. Equivalent expressions. So you have to recognize, you might see something like this and something like this. Now here's how the triangular pieces work. For instance, one might have 2x minus 4 on it, and the other one that you're going to match to it is going to have this 2 times x minus 2. And you're going to put those 2 pieces together. Each puzzle piece is going to match, like this side will match the next triangle. And you're going to build a very large triangle made of smaller triangles, like this, that all the edges are equivalent to each other. It works. They did it in the first section. You guys ready? Okay, let's get started. No, it's because you have a variable and you have a number. So you have to leave your numbers and your variables alone. You can't combine them, can you?
No.
But you could add something here. What is 2x plus 3x?
5x.
Okay, is there any 5x's anywhere? Do you see a 5x?
No. Mine can't find it.
No, but it might not be there, right?
Yeah.
So what about this right here? Do you see this right here?
3x, yeah.
Okay. What do you have over there, Sabrina?
I got 3 X's.
Do you have 3 plus 3 plus 3 x's? Hey, there you go. So there's a match, right?
That makes
Okay,
that
perfect.
makes
So keep going.
Wait, 0 goes this way. 2x plus 2. What?
Wait, 0 plus x. Is there
I know. No, these ones go together.
Yeah, that's what I'm saying.
2 equals 10 plus 2 go together. These have to go together. So that's
5y plus 3.
so this one goes with this one.
Yeah.
Because 10y plus 4y and 4y plus 1. I didn't screw it up. I got them right.
Yeah, but you messed up.
Wait. Plus x plus 1.
2x. Yeah, so this would go under there.
2 plus x plus y.
Our tower is looking untowerish.
Remember, it's going to look like a triangle when you're done.
7x.
It's a big triangle puzzle.
2y plus 7y.
And they will all fit if you get them in the right orientation.
Equals to 35y.
Yeah, we got 12y. We get 5y plus 7y.
35y.
And then this one goes, I think.
Oh my god, 35y?
Or did not.
Oh wait, no, 2y. This one goes here.
I don't know if this is making a triangle.
No, it will. It has to. Alright? I think it
Is it really gonna make a triangle?
Mhm.
Laughing. He's not right. Because I feel we're getting them. Wait, 6
What's
plus
12 minus
x,
5
we have a
is-
6.
Cars. Maybe we should move the broom, huh? Oops.
Don't broom!
All right.
I hate brooms. Wait, Brown, if it goes to the side, should we just measure like up?
Yeah. Do the best you can.
I'll do it from here. Ooh.
So what is this test? 4 inches, 6 inches, what?
6.
Okay.
What happened to this calculator?
Charge.
Really?
All right. Measure it.
Charlotte.
remember these wind up clocks from us when we were kids.
62 or whatever.
Alright, so class, what we did is we put all the data into Desmos. As you can see, let me shrink this picture a little bit. If I drag this up, what happens is, there's everybody's data. You see, there's all the data in Desmos that you put in based on measuring the car length. So this particular line, this is team one. For team one, you can see this orange line is the line of best fit for that team. So if I change these to team two, there would be a line of best fit. And one of these, I mean, we could take the average of every single block and get sort of a line of best fit for all the data if we wanted to do that, if we were going to use this data for something. But for the purposes of what we're doing is, remember, there's going to be a finish line, and your job is to roll your car up to the finish line without touching it. And I'll show you a picture from first class. Somebody got like within 1/8 of an inch and did not touch the tape. It was pretty amazing. All right, so based on this data, if I look at the data, I am going to set the finish line. I'm going to set it at 82 inches, all right? 82 inches from the front of there is going to be the finish line, all right? So team one, are you ready? So I'm going to use each best fit line. So team one, based on this data, if I go to 82, so if I zoom in, and I come over here and I go to 82, it's right there. And I come over to this line, 82. And I click on this thing, it says, for you, wow. For team one, you need to pull it back right at 10 inches. You see the coordinate there? So that's not quite 82 inches, right? 81. You see what I'm doing here, etc. So you don't want to go over, right? So you need to figure out, do you feel comfortable pulling it back 10 inches to see what happens? All right, team two. Not bad. Let's see how he does. That's a long way from the finish line. Ooh, I get the finger. All right. So today, class, is our introductory lesson to volume. And the problem you're going to solve is, if this huge ice cream cone full of 4 ice cream scoops, full of ice cream in the cone, melted, how big is the diameter of the cylinder it would make if the height of this puddle is 0.1 feet tall? So 0.1 feet tall, it melts into this big huge puddle. What's the diameter of the puddle? That's the question. Okay? So what do you see in the picture? Okay? And? Store, yeah. So what are the 3 shapes? What are the 3 shapes that we're going to work on? I just described them a little bit. What would you call this ice cream scoop? What's a 3-dimensional circle? A ball? A sphere, right? Okay, sphere, yep. And what is this 3-dimensional triangle thing? A cone, right? Like the elf's hat, dwarf's hat, witch's hat, whatever, right? Cone, and then this was a cylinder, like a soup can, cash can, etc., right? So we have 3 different geometric shapes here. They all have volume, right? So how are we gonna go figuring out how much ice cream there is? What do we need? What questions? If you ask me questions, I will give you some hints and or tips on the things you might need to solve this. What do you think? What do you need to solve this? Crickets. You can ask a question.
All right. What is the area of the spheres of ice cream that are going to be covered?
What is the volume of the
Volume
spheres?
areas.
The volume. So how would I find the volume of the sphere? Is a good question. You know? Is that useful to know? You think that okay, volume of the sphere, probably useful to know. Because that would tell us how much those 4 scoops of ice cream are, right? All right. What else? What other volumes do we need? What did you say?
The volume of the cone.
The volume of the cone. How do we find volume? How do we find area?
Base times height.
Base times height.
Base times height.
So let's think about a cylinder for a moment. What's the base down here?
Base is the diameter.
The base is the area of the circle. What's the area of a circle? Remember?
It's or pi times r.
Pi times r squared times the height, right? Height equals the volume of this cylinder. Okay? So that's interesting. So that describes the puddle for us. Right? We're ultimately going to have this puddle. We're going to have a height of the puddle. Hopefully we'll have figured out all the volume of this stuff, which we can put over there, and then solve for this diameter. That's what we're after. So $2. What do I do? Spin the wheel. Spin the wheel. I lost. Let Gilla rip. Oh, try again.
You lose it. Huh? You lose it.
One more try.
Catherine.
So I have to decide, do I want to give my waiter, who was terrible, a tip on this or on this? Because this is going to be less money for me, and they were pretty terrible, right? So if I decide I want to give them a tax on this part, then I'd take 92.24, and then I can tack on whatever I decide for my level of service, and then add it to that. 1.12 is your 12%, right?
Wait, wouldn't that just be double our juice?
Yes, it would. Yes,
Wait, so
it
we
would.
just do
$11.06. 1.7. She doesn't need $11.
Well, on $100 bill, yes, she does. Or he.
Libby's was 23
Look, he works hard for his money.
No, you didn't.
I'm just saying.
You were on your phone.
Yeah.
You got a napkin thrown at you,
Look
okay?
at the fountain drink that I never got. Wait, where's
Guess what? Okay, I wipe my dirty hands on this.
Yeah, it's a towel. Wait, the on the table.
You're taking this way too seriously.